All right, so we want to see the graph of a system of inequalities. So what you're going to have, you'll have two inequalities. We're going to find the graph and the shading for the first one. We'll find the shading for the second one, but the answer is going to be where those shadings overlap. So let's look at the first one. Okay, I have my x and my y axis. Now my first equation, or my first inequality, is already in slope-intercept form. Y equals mx plus b. So I'm going to graph it like a line. That didn't come up there. The b is -1, so on my y at -1, I plot my first point. Then from the -1, I'm going to slope, rise over run from my point 2 units. So that's going to have me go up 1, 2 units, and then run 1 unit. Since I have an equal sign here in my inequality, this line is going to be solid. Remember, if there's not an equal, I have to dot my line. And be real careful when you look at the equations that I have down there for you to pick from, because some of them I will have dotted and some of them I'll have solid. Make sure you pick the right one. This one has to be solid. So let's get this guy up here. I mean, this guy isn't wanting to cooperate with me today. There we go. Okay, so there's line 1, and I like to label it, if you remember, so that I can keep up with which one's which. So that's the first one. Now the second one is not in slope-intercept form, so I'm going to want to put it into slope-intercept form. Let's do this one over here. So let's bring him down here. I want it in y equals mx plus b, so let's subtract the 6x. 3y less than or equal to -6x plus 9. So y equals mx plus b. Got to divide through by 3. If I divide through by a negative, what do I have to remember to do? Flip over that inequality sign. So let's graph this one in red so we can see the difference. This time I graph the +3. So 1, 2, 3. And from there my slope is -2. So I'm going to drop 2 and run 1. Drop 2, run 1. That puts me right there. How about that? And I made that one up. Couldn't have been prettier. Okay, now let's look at our shading. On the first one, the black line, remember that we pick a point that is not on the line. And I like to pick, 0, 0. If it's not on the line, because 0 gives me the easiest arithmetic to deal with. So I'm going to have 0 is greater than or equal to 2 times 0 minus 1. See, I'm checking right here to see if this is the true side of the black line or the false side of the black line. Is 0 greater than or equal to -1? Is that true? It is true. So that means that everything above the black line makes the first inequality true. Now let's see about the red line. When I go to the red line and I plug in 0, 0, then I'm going to have 3 times 0, 6 times 0. So I'm going to have 0 plus 0 less than or equal to 9. Is 0 less than or equal to 9? That's true as well, isn't it? So the 0, 0 is true for everything below this red line. So I want everything above the black but below the red, and that's going to give me that part right in there. Do you see? So anything within that blue space, including this red line and this black line, will make my inequality true. Okay, summing up, we graph them. Y equals mx plus b, put the b on the y-axis, then slope from the b. test that 0, 0 point. If 0, 0 is on the line, select another easy point, like 0, 1 or 1, 0. Something that's going to make arithmetic really, really simple. Because you're looking for the true side of each line, and where the true sides overlap, that is your answer. Remember, this is multiple choice, so as you look at this, you'll look below and you'll see which one you need to pick from, okay? Now remember, tonight, if you come across questions while you're studying, send them to me. If you want some help, and I'm happy to either send you the recording back or just work the problem and see. Like that? Is that what you're talking about?
No, the other ones.
Okay.
No, it's
Something like, and then we're going to have, now this, I made this up, so it's probably going to be an ugly fraction, which is fine, okay? All right, now when you're doing a system, and if you're told to do an elimination, remember that we have to have them lined up. X plus y equals constant and x plus y equals constant. And the first one is set up like that. 2x plus 5y equals 7. It's this guy that we've got to put in the right order. So if I take that little guy and add 3y to each side, then I'm going to have 1x plus 3y equals 4. Now, if you have to solve this using elimination, you have to either decide, am I going to eliminate the x or am I going to eliminate the y? Which would be easier for me as an individual to do? Because what might be easy for Caroline to do and what might be easy for Carly to do might be totally different ones. Okay? So which one, Carly, since it's your problem, do you want us to make fall out? The y. So you're going the hard way. No, we can do the y's. We can do the y's. Because you're going to have to multiply 1 through by 3 and 1 through by 5, and you're going to have some really big numbers. See, I can make that bottom one. I can just multiply it through by -2, and I have opposites right away. Okay, but you can do the other, okay? You can do the other. There's nothing wrong. So there's no right or wrong as to picking. Okay, as a matter of fact, I probably shouldn't have even said that. I should have gone with it. So we're going to multiply the bottom one through by -2. So let me repeat the top one. And then as I multiply through here by -2, let's see what happens. -2x plus 2x is 0. That falls out. And I'm going to get a -1y equals -1. This worked out pretty good for one that I just made up. And then multiply both sides by -1. Y is 1. Now remember, the answer here is an ordered pair. We're looking for the point where those two lines cross. So now that I have found what the y is, I plug that y into one of my original equations, whichever one I think is going to be easier to solve. Which one, top or bottom? Bottom, okay. So I'm going to say x equals -3, y plus 4, but we have found that y is 1. So x equals -3 plus 4, x equals 1. I cannot believe one I made up came out that pretty.
We have to plug it into the original one, or can it be, like, you have to switch it so that it's like
Okay,
X?
I like to go back to the original one just in case I have a problem. Not just in these problems, Paolo, in any math problem that I do, if I have to go back and plug in, I like to go back to my original so that if I made an error somewhere down below that, I might can catch something. But if you're pretty sure of your work, you can check. You can put it in somewhere else. Showed you. So now I'm going to bring down exactly what I have, that the absolute value of x minus 5 can be greater than 3. Or, if I look at the other end, I'm going to go below -3. So my x minus 5 could be less than -3. Remember, we flipped this, and the sign of this one will always change. See how it changed? You're going to have two changes going on when that happens. So as I start to graph, OR is the union of both sets. So I'm going to graph all of the first answer and all of the second answer on the same number line. Add 5. So the x's that are greater than 8, not including the 8, because I don't have an equal sign. And then my x's that are less than 2. And there you go.
And when we solve the inequalities, like without doing these lines and everything, we have to write like, wait, let me see this. No, inequalities, like just inequalities. How do we solve it? Like we just do like if it was an equal sign, right?
Yeah. And then you mean on the graph board, on the intersected axis, or on this? On the number line?
No.
You're talking about like this first. Read me a problem.
Oh, it's another line. You did that on.
Okay.
Did she answer your question, or do you want? Okay. Okay. Another question?
So there's graphing inequalities and system of inequalities, right?
Graphing inequalities and system of inequalities.
Because the system of inequalities, when you have two equations.
You have two, and you've got to graph the overlap of them. Yes.
Freshman's exams are the only ones that are 10% of their grade.
We're easing into them, making them, a little bit more accountable, because when you get to college, then, it can kind of be. Some professors will only give an exam, and that'll be your only grade. Some will give just a midterm and a final. So we're trying to not destroy your grade at first and ease you into them. Okay. Okay. All right. So, exponents. Let's start with the basic of exponents. Remember that, let's say anything, we'll just say 27 to the 0 power. Anything to the 0 power. Anything to the 0 power is always the number 1. Okay, so don't get tricked on that. Okay, anything in 0 power is 1. Now, if I'm multiplying like bases, let me go back use A.
Chapter 8 has a lot of questions.
If I'm multiplying like bases, I'm going to add my exponents. Okay? And so if I give you x to the 5th times x to the 17th, the x remains an x. The base stays the same. That doesn't look much like a 17. How's that? And then I add my 5 plus my 17. That's going to be 22. If I am dividing like bases, I subtract my exponents. So if I have 15 or 14 to the 15th over 14 to the 9th, that's 14 to the 15 minus 9, which is 14 to the 6th.
You don't divide 14 over 14?
Its base stays the same. And y'all can use your calculators, by the way.
So if it's like instead of 14 and 14, if it's 17 and 14, is it going to
Oh, I couldn't get. You can't combine it.
Can I get a calculator for me tomorrow?
You can take one of these. I've signed mine out, but these two were ones that were left in here. I don't know who they belong to, so you can borrow one of those. These are the only two I have left. So y'all can fight over them, okay? Because my others were signed out. Okay, now let's look at what if I have a power raised to a power. Let's say we have y to the 1/2 to the 4th. When you raise a power to a power, you multiply them. Again, that base stays the same. So you just multiply those together, and that's going to give you y to the 2nd. In solving equations, we had some, I think you pointed out to those, like if I have x to the 1/2 equals 4, something like that. We said, let's take that number down to the lowest base we can. And we would take it down like 2 to the 2nd. So I had x to the 1/2 equals 2 to the 2nd. Then, remember, we can raise each side to the same power. And when I multiply 2 times 1/2, I get x to the 1. And that's going to give me 2 to the 4th, because 2 times 2 is 4. So x equals 16. Okay. Again, I will post this. This one I left off the 0 on your quiz, so if you just factored it, I left it at that, because I had been harping on you just to, the ones with 0 you solve. So if you didn't put the equal 0, I'd only let you factor it, but if you put the equal 0, I'll win. So that was not relative to your answer. But on this one, we have to factor this guy. So what I want to do when I factor, and this a is not a 1, I want to use that method that I showed you if I'm not going to use trial and error. Okay? You like trial and error a lot, because you can see through them real fast. I used to be that way. I get to where I have to do it, the multiply, because I get used. My brain locks in on a way. So I'm starting to lock in on this one and really, really find it the easiest. But either way matters. Doesn't matter. So I'm going to multiply these two together, the A and the C, and I'm going to get 40. Now remember, those two guys that I've underlined, they've already done their share of the work. So they get to just come down here and rest. Now I'm going to list my factors of 40 in their pairs. For instance, 1 and 40. Hey, come in. 2 and 20. 3 won't go into 40, but 4 and 10. 5 and 8. And I'm looking for one that will add or subtract to give me that negative 13. And that 5 and 8 will do it. So I can have a negative 5x and a minus 8x, and the order doesn't matter that I put them in and replace my negative 3x. So which do you want to put first? David, since this is your call, do you want to put the 8 first or the 5 first? It doesn't matter, just 8. Okay. So we're going to put negative 8x minus 5x. Now look and see that this second line is the same thing as the first line. I've just changed negative 13x to negative 8x minus 5x. And remember, a majority of the test is factoring. So you saw that in your study guide. All right, so here we go. Now we're going to factor by grouping. So let's put these first two together, and my GCF is going to be what?
It's going to be 4.
4. And what about a variable? Do I have a common variable? X. And that's going to leave me with x minus 2. So remember, over here, when I put these two together, I want an x minus 2. Those two parentheses have to be the same, or I'm not factoring by grouping. I've goofed. So what should I factor out of this blue parentheses here, such that I would have left inside x minus 2? Negative 5. Excellent. So I pull off that common parentheses. Whatever is left goes in the second parentheses. That's why it's so critical that you put that sign there, whether it's a plus or a minus. because it's going to be down here. So here's your factored form. So for those of you who left it there, like I said, because I left off the 0, that was fine. But if we take it down further and work it like I should have if I had put the 0 on, we would have taken each parenthesis and set it equal to 0. That's because when you multiply numbers, it doesn't matter how many numbers I'm multiplying. If one of those numbers is 0, it's going to wipe everything out to 0. So we're saying x minus 2 might be the factor that's wiping this thing out to 0. And if that's the case, then x would have to be 2 to wipe this out to 0. But it may not be the 0 factor. 4x minus 5 might be the 0 factor. Okay? So let's solve and see what x would have to be to make that second parenthesis 0. I'm going to divide by 4 now. So x could be 5/4, or 1 and 1/4. So my two possibilities are 5/4 and 2. Those two numbers would make, when I plug in the original, would give me 0 after I plug in. You just what, honey?
Are we allowed to leave after our exam?
I think you have to work on it at least an hour, maybe an hour and a half. And then after you've worked that long, then you're allowed to leave, but you have longer allowed if you want it.
So,
In
Okay,
the-
after our exams, we're just allowed to leave
Start
school.
at 8 o'clock in the morning?
Yes, they start at 8, not 8:30 like school. It's 8 o'clock, or like they were last year, so. Okay, so which one of these, Paolo, are you talking about, or do you want to see both of them?
Both.
Okay, so the first one, when I take something to a third power, remember whatever this denominator is, like the bottom of a tree has roots, that's going to be my root. That's going to be the number inside the little radical. And then under here, I'm going to have 125 to the first power. So what this is asking me is, what's the cube root of 125? Or what number, when multiplied by itself 3 times, gives me 125? What is that?
7.
7 times 7 times 7? No, if it ends in 125, what are you thinking it might be?
5.
5 or 15? Those were the ones I'd try first. And this one, in case, it's going to be 5. Now, you can do that on your calculator. Do you have a one of these?
Right now, no.
Will you have one on the exam? You can go to math and down to number 4. It's the cube root of, and just hit that. And you could put 125. Kaboom, 5. So you can do that. It's under the math, under math.
Okay.
Now the other one is an equation. That's what's different about it. We have an equation there. So I want the 6 and the 216 to be taken down to the smallest base that I can get them, and I'm hoping and praying that that base is going to be the same for each of them. Well, 6 won't go down any further. Nothing times itself is going to give me 6. So I'm going to hope that I can take the 216 and make it 6 to some power. So let's just see. 6 times 6 is 36. So that's 6 to the second power. And then times 6, there it is. So 6 to the third power is 6 to the x. So what would x have to be?
6.
X has to equal 3.
So the base has to be, it always has to be the same.
Well, yeah, we want it to be the same.
Is there like a no calculator part where we can't use our calculator?
No, I'm giving you a calculator-free zone. Well, that sounds like I'm not letting you use it. You can use it on the whole test.